Alright, y'all, so this is the video for chapter 2.8. This is going to be dealing with essentially rational inequalities, basically, or basically just, polynomial, not rational inequalities, excuse me, I'm solving polynomial inequalities. Now, for the first question, basically the prompt of this, basically the first step is, we're basically going to determine all the real number values of x that will cause f of x, again, this function up here, to be 0, positive, and negative. Okay. So let's find out all the numbers that will, real numbers, again, that's actually important, real numbers that cause f of x to equal 0. Well, we would literally just, that would just be setting all these equal to 0. Set x, so put 0 here. X plus 3 equals 0, we get x equals negative 3. We just put x minus 4 equal to 0, we would get x equals 4. However, now, the reason that I stressed it had to be a real number value is for that second part there. If you set x squared plus 1 equal to 0, and I'm pretty sure a lot of you can see where this is going. You're going to get x squared is equal to negative 1. And you're going to get x is equal to plus or minus I for that, which does not work. Again, it has to be real numbers, and that is an imaginary. So that does not work. So again, those are all the numbers. Those are all the real numbers in which f of x is 0 is 0. Now let's do positive. If we do this first one, well, basically it's any number that is greater than negative 3. Well, basically you can set this x plus 3 greater than 0, solve for x, you get x is greater than negative 3. For the second one there, if you look at it analytically and you really think about it, all real numbers that you plug into this one are going to be positive. Because again, any number, either negative or positive, any real number, negative or positive, when squared, is going to give you a positive number. And if you subtract 1 from that, and then if you add 1, it's going to just be positive. So any number here is going to be positive, even if you plug in 0. It's going to be a positive number. So it'll basically be all numbers for the second one. But basically, we wouldn't even have to write down any kind of limits for that. And then for this last one here, again, it's squared. So basically, majority of anything that we plug in here is going to be positive because, again, if we plug in a negative number, all of it's just going to be squared, which will always give us a positive number. The only difference is that if you plug in a 4, it's going to give you 0. And this has to be exclusively positive. So then we would have a criteria of x is does not equal 4. And then lastly for negative, as I said, basically these two right here are never going to be negative. So essentially the only negative criteria that we will have is if x is less than negative 3. So it says use your results to solve the 4 inequalities associated with the polynomial above. I'm actually going to, that is right here, I actually wrote those out ahead of time. I am actually going to take what we just did there and create what is called a sign chart. Now, sign chart is essentially just kind of a chart where you will plot your zeros that you get, basically the numbers that will equal 0, which we said was negative 3 and 4. And then basically in between, with these intervals here, basically negative 3 to negative infinity, 4 to in between negative 3 and 4, and then 4 to infinity. We're basically just going to determine whether or not the function itself is either negative or positive. So anytime that we are less than negative 3, we already established that less than negative 3 is going to make this negative. the first point negative. So basically this is just a stand-in for the x plus, for the x minus 3. X, let me see what that, for the x plus 3, excuse me. Then the second term in here, this is always going to be positive. Again, this is a stand-in for your x squared plus 1, because it's always going to be positive no matter where you're at, no matter what number you plug in there. And then for this last one here, again, a stand-in for our x minus 4 squared. If we plug in a negative 3, well, that's just going to give us a negative here. But again, that number is also being squared. Alright. Then from here, you would take the negative. Again, you would basically then just kind of multiply out your signs here. Negative squared would give us a positive right here. Negative times a positive, which would give us a negative, times this positive, which would give us a negative. So essentially, f of x is going to be negative if x is less than negative 3. In between here, well, if it's greater than negative 3, then this first point here is going to be positive. And again, the second point, always positive no matter where you're at. We're still less than negative 4, so it's going to be a negative squared here. However, again, as we know, negative squared is going to give us a positive. So essentially, we just got a positive times a positive times a positive, which is essentially just going to give, in this interval here, we're going to get a positive. And then for anything greater than 4, well, again, we're greater than negative 3, so this is going to be positive. The middle term is always going to be positive. X squared plus 1, always positive. Then this next term here, because we are greater than negative 4 now, it's going to be a positive squared, which all that is positive, which when multiplied out is going to give us positive. So, knowing all of this will allow us to solve these inequalities down here. So, our function, when it is greater than 0. When it is greater than 0. Now again, we start with our lowest term there, that it can be 0, which is we know is negative 3. When it's negative 3, it's going to be 0. When it's less than negative 3, it's going to be less than 0. But because it has to be just exclusively greater than 0, here we have to write in parentheses to negative 3. Negative 3 parentheses. And then because 4 is also going to be equal to 0, that's going to be a part of our answer as well with a parentheses. And then we put the u parentheses 4 right here just to kind of tell us that we're skipping over the 4. And then everything basically from 4 to positive infinity would be greater than 0, so it would be infinity. And then for the next one, anytime that is greater than or equal to 0, well, when it's equal to 0, when it's negative 3, so we're going to add negative 3 into our equation, into our answer. However, because it is negative 3 inclusive, we're going to add a bracket here. And then negative 4 also is when it's equal to 0, but we don't really need to add it because it's already included in our. If we just put infinity here, it's going to be included within that interval. So that's what that would be. When it's greater than or equal to 0, it would just be negative 3 to infinity, negative 3 inclusive. So what about when it's less than 0? Just less than 0. Well, we know that it's basically just any number that is less than negative 3. And again, so we start with negative infinity, work our way up to negative 3, and because it is just less than 0, it has to be the open bracket, and not bracket, excuse me, parentheses. And then it is when it is less than or equal to 0. Well, again, we would kind of start off with our start down here, negative infinity, go to negative 3, but negative 3 inclusive because negative 3 is equal to 0. So we put a bracket in there. Well, we also have this 4 to deal with. Now, this 4 is kind of out here on an island by itself. It's equal to 0, but anything in between it basically in between -3 and 4 and infinity is all positive. So essentially we would same what we did up here, write a little U shape, and we would literally just bracket in the 4 by itself with no interval. That essentially is just telling us that the 4 is its own, that it's basically this interval, any number from -infinity to -3 inclusive, but also including the number 4 and just the number 4. Okay, so that is the using sign charts in order to solve inequalities. So now let's solve a polynomial inequality analytically. So now we're solving 2x cubed minus 7x squared minus 10x plus 24 when it's greater than 0 without using a graphing calculator. Well, one thing that we can definitely do here is use our rational roots theorem in order to get our list of possible rational roots. Going to be plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 6, plus or minus 12, and then plus or minus 24. All that over the factors of the leading coefficient, plus or minus 1, plus or minus 2. Divide all those out and you get your possible rational roots. Just for the sake of time, I'm just going to already establish that one of the possible rational roots is 4. Again, when plugging it in, when you plug in 4, you should get it equal to 0, which means that is one of your roots. Using that, you should be able to synthetically divide and then when synthetically divide, you get the coefficients of a quadratic function down here. So again, let's do this. -6, -24, and 0, so that works out for us. These are the coefficients of our quadratic function down here, so we got that it's 2x squared plus x minus 6. And again, that is its own, where's the dang thing at? And again, once we get to this part here, we should be able to factor this quadratic out. And it factors out to x minus 4 times 2x minus 3 times x plus 2. And then from there, from there we can make our sign chart, because again, when we set all these equal to 0, they're going to basically be our zeros. So you start with a -2, you'd have a 3/2 in here, you'd have a positive 3/2 in here, and then a positive 4 out here. All these numbers are going to be sign changes, because these are all multiplicities of 1. It's going to be negative right here, and then positive right here, because we know that our end behaviors. Negative as it goes to negative infinity, positive as it goes to positive infinity. Our sign, then it's a sign. Then all these are sign changes, so this is going to be positive, this is going to be negative, and then it'll be positive. So if we're looking for any time that the function itself is greater than 0, we basically know that we're just looking for our positive intervals, basically our intervals in which it's positive. -2 to 3/2, and then 4 to infinity. And again, it's all exclusively greater than 0, so just remember to use your parentheses rather than your brackets. And again, so again, whenever you're solving these, make your sign charts with your numbers that make your function equal to 0. So basically, solve your function, get your zeros, put that in your sign charts, and then determine, and then using the numbers in these intervals here, determine whether or not it's positive, the function is positive or negative, and then you should be able to solve the inequality. That concludes the 2.8 video. Thank you for watching.